Hey everyone, Wazoo here, and in this video we are going to be digging into some PhaserJS. Yeah, I've been able to spend some time over this summer so far working on some game development projects, and I thought it would be a nice fit for this channel. As you can see in front of me, we have got a neat little Asteroids clone game going. It is called, or I gave it a name of Meteor Swarm, which is just a bunch of asteroids floating around, and you control the little player character. You're able to take some shots when you have a clear hit against a meteor, and as you hit meteors, they're removed from the game board, and your score goes up by 10 until finally all of the meteors are cleared, and then the game is over. So I'm really excited for this video. I think it's going to be a lot of fun, and I'm hoping that you learn a lot. I think it'll be great. Okay, so first things first, just make sure you have Node and NPM installed. I'll provide a link to my free guide that I've got up on Gumroad, which details how to install and set up to get everything ready on your system for working with PhaserJS. I'll leave it there in the description down below. And so we will jump right into creating something. So we are going to be using Vite to bundle our PhaserJS game together, which is a really small, lightweight, but fast bundler that I've been using quite a bit on JavaScript projects. Type in npm create Vite at latest, and it will start the process of creating our project. We're going to have to answer a few questions, and then it will generate everything for us. Okay, so here we have a project name. So let's give it a project name of Meteor Swarm. Well, let's call it Phaser Meteor Swarm. Okay, and we're going to be using vanilla. And we're going to be going with a JavaScript variant. And that's it. See how quick and easy that was? So let's go into that folder. And we can run npm install. And I will also npm install Phaser, which is the game framework library that we're going to be using. Okay, so I will then be opening up the project in Visual Studio Code, but you get to use whatever editor you find productive for you. Okay, so let's zoom in a little bit here. Okay, so the Vite.js default project setup gives you of course, a package.json. We've got a few scripts to look at. We've got a dev script, a build script, and a preview. Now, we're not going to be using preview in this video, but we're going to be using dev, and we may end up using build at some point. But dev will just run the local dev server to verify and test everything that we're doing in our game. And as you can see here, we've got Phaser 3.80.1, and the default entry point will be the index.html here, which will then reference our main.js file, which is over here. So we've got a default bit of markup here, and if we run npm run dev, we'll run the local server in dev mode, and as you can see right here, where our link will be at localhost port 5174. Okay, so as you can see, we've got some default images coming up here. We've got a Hello Vite component text as well as a button component. Whenever we click on this button, it will increase the counter that is displayed on the label. But we don't need to care about this. This is just the default JavaScript that comes with the Vite project setup. So let's go ahead and let's just comment out this whole thing. We don't need it. And then what we're going to do is we're going to import Phaser from Phaser. And we are going to create a little game configuration to initialize and start up the engine. So we'll call it a config variable. We'll give it a type of phaser.auto so that this Phaser will then is smart enough to understand the system that you're starting this on. And it will either generate a canvas, an HTML5 canvas object for you to work with, or a WebGL friendly canvas. And let's see, let's give it a width. Oops. Let's give it a width of 800, a height of 600, and we'll set up some default physics. This is for working with the physics engine that comes built into Phaser. So we are going to be using the arcade, and we don't want any gravity to affect our calculations of our objects. So I'm just going to say gravity y of 0. And then I'm going to enable something called debug. So debug true. And what this will do is this will draw little squares around our sprites that we want to display on our field. It's really cool on our game. And that way you get to visualize where objects are, and it helps you to do any kind of debugging. And so let's give it a background color of cornflower blue, which is hash 649-5ED. And that should be good to get us started. So I will just say const game equals new phaser.game, and we pass in that new config object. Now we should have our server still up and running. So let's go back to our browser. And we see after a refresh that we have our 800 by 600 container, which is clearing in cornflower blue. All right. So now we get to work on scenes. So in Phaser speak, Phaser likes to break things down into different scenes that you can use for the organization of your game state, basically. So if you think of a simple game like Asteroids, you've got maybe a title screen, which displays a title and logo. Then you've got a state where you're going in and playing the game. And then maybe you've got a win or a lose state, depending on the kind of game. And you might even have like a high scores state where you like display the title screen. And then after a few seconds, you display the high scores. You know how the old arcade machines used to have that kind of attract mode. So we can set up the same thing in Phaser. Phaser has a thing called scenes, in which we can set up the same type of behavior, where for different states or phases of the game, we can have a particular scene to work with each one. This will help us keep our code organized, and it'll be a little bit easier to debug as we go through this. So let's create a new folder in our project root called scenes, and we are going to start with what's called a loader scene. So loaderscene.js. And so what we're going to do here is we're going to use this for loading up all of the assets that we're going to be using in our game. So we've got a few sound effects, and we've got a few images that we want to load up. And so most Phaser projects recommend that you create this kind of loader scene to handle the preloading of all of these assets that you're going to be using for your game. And then that way you can reference them from the other scenes. You don't have to worry about reloading anything. They're all in memory, and they're all available to use throughout the rest of the execution of your game. So we're going to import Phaser from Phaser again. So we'll call it loader scene, and we are going to be extending Phaser.scene. And so we have a constructor, and now we have to call the super method, and all we need to specify is sort of a tag name of this scene. So we're just going to call it loader scene. And this is really helpful for when we want to use Phaser to switch between the different scenes. All we have to do is reference this tag name that we're using, and Bob's your uncle. So every scene has a preload callback, which is a function that's triggered by Phaser, which we will then be using to load up all of the assets that are going to be in this project. I recommend you just download the zip file for this project. It'll have all the assets in there. I got them off of Kenny.nl, who is a popular indie game artist. He creates a lot of free assets on his site, So if you haven't heard of him or come across him by now, then it is an excellent resource for grabbing some assets that you can use to play around with and test. So all we need to do is call this load.image. We're going to be loading some images first. Now, the first thing we're going to need is a name that we can give each image. So like a key name. So in our case, it is going to be player. And then we're going to give it the path to the file name. So assets player.png. And I'm going to do the same for the other images. Okay, and then we're going to load some audio, and it's the same type of syntax, this.load.audio. So we're going to be loading two audio files. One is for our shot, our laser shot, and the other one is for an explosion. So when a laser beam hits a meteor. Okay, and then finally we are going to be loading a bitmap font. This.load.bitmap font. And then we pass in the name of the font that we want to use, as well as where the assets are for Phaser to load in and put this font together. So this can be any font name that we want to use. This isn't the actual name of the font. I mean, in this case it is, but it doesn't have to be. It's just, as with these other assets, it can just be a key name. So in this case, we're using a key name of arcade. Okay, so let's go ahead and save this. So back in main.js, we can include a reference, import LoadingScene from scenes LoadingScene. And then here what we're going to do is we'll make an entry, we'll add an entry to the config called scene, and this is where we pass in an array of the scenes that we want to use. And so our first entry is going to be LoadingScene. Now, it doesn't really matter at this point because we only have one entry, but Phaser will automatically attempt to use the first given scene object as the initial scene state, if that makes sense. So when we start adding different scenes to this, just make sure that the LoadingScene is always first in the array, because it will be the first one that Phaser will load up as it's processing all of your scenes. Okay, and back to our browser here, and you can see that we've got a lot of failures, and this is because we don't have the image assets copied in yet. So I'm going to quickly do that now. Okay, so I've copied the assets into the public folder, assets, and then here they all are, along with our fonts. And everything should load up correctly now. And it looks like it does. There's no more errors showing up in the console. Okay, so once the loader scene has finished, once this preload function is finished up, then what we can do is we can overload another function called create. And this is a function that gets called after Phaser is finished with the preload function. So let's give it a name of create, and then we'll use this.scene.switch, and then we'll use the key name of MainMenuState, which we haven't actually created yet. We will do that right now. So we are going to be switching Phaser to use our next scene that we're going to create called MainMenuState. So let's create a new file in the scenes folder called MainMenuScene.js. And we've got a similar first few lines. Okay, we're extending the Phaser.scene object. We are specifying a constructor with the super method and passing in the key name of MainMenuScene. We've got a preload function, but since we've already preloaded all of our assets in the loader scene, then we no longer need to worry about it here. So let's go ahead and provide an override for the create function. And so what we're going to do is we are going to grab the width and the height of our game field, our game display, and we're going to put some text right in the middle, basically the title of our game, Meteor Swarm. So let's grab the width, which is making use of this .cameras.main.width and a height of this .cameras.main.height. And then we'll make use of that bitmap font that we loaded in the loader scene. And we're going to call a method called add. And this is a very important method from Phaser. So what we are doing is we are adding a game object into our scene. And then Phaser will take all these game objects and it will then attempt to render them every frame through the scene, as well as make use of them when they're updating. So you'll see what I mean as we continue throughout this video. So here we're calling this.add.bitmapText, and we're specifying a width divided by 2 and a height divided by 2 minus 50 pixels. And we're using the arcade font, the arcade bitmap font, and our title, Meteor Swarm, and we're giving it a font size of 40. Okay, so don't forget that we have created this main menu scene, but now we need to add it into that array, that scene array in the game config object. So back in main.js, let's go ahead and import MainMenuScene from scenes MainMenuScene. And remember, we'll put it second in our list here. So MainMenuScene. We also needed to add a set origin of 0.5, and this will help adjust the text into the center of our display. So taking a look here, we've got Meteor Swarm coming up. And so this is our title screen. And then I figure what we can do is when you hit the spacebar, then you launch right into the game. So let's go ahead and code up how to access the keyboard in PhaserJS. Back in the create function of our main menu scene, let's grab what's called the cursors. So all we need to do is type in this.cursors equals this.input.keyboard.create cursor keys. And so every frame of this scene, the current keyboard mapping will be shoved into this.cursors that we can access and process. So another function overload that we can provide for every scene is called update. And as you might imagine, this is called every single frame of our game. So let's provide an override for update. And all we're going to do is we're going to look for the spacebar and then advance to our play scene. So if this.cursors .space, so if the spacebar is down is all true, then we want to call this.scene.switch PlayScene. Okay, so that should be all we need. So if we hit the spacebar, then we will try to switch to the play scene. So let's create a empty scene there now. If you create a PlayScene.js file within the scenes folder, then we'll do the familiar routine of extending the phaser.scene object, importing phaser, and we are calling the super function in the constructor, giving this a tag name of PlayScene. So we have our preload method override, and we're not doing anything, of course, because as I've said before, we've already loaded all of our assets in the loader scene. So maybe what we'll do is we will add the player, and then we will try to work with the player before adding our meteors. So in the create function override, let's just create a player. So this.player equals this.physics add, and we're going to add just our image. Let's see, we'll put it at 200, 200. And our texture is that string key that we gave it during the loader scene, and we used player. Okay, and since it is our player controlled ship, we're going to just set a few physics variables. So this.player.set drag, and we're going to give it a value of 0.99. And we're going to define a maximum velocity. So this.player set max velocity of 150. Again, of course, in our main.js, we have to reference that PlayScene. So let's import PlayScene from /scenes PlayScene. And then, so right after the main menu scene, let's define PlayScene. Okay, and we should load up, hit space, and we see our player. Now remember how I mentioned in the beginning of our video that the config has debug true enabled, which will then draw these rectangles around our sprite objects. So you can easily turn them off by saying debug false, or just commenting out this line altogether. And you see it's gone here. I just like them enabled just so that it might help with any kind of physics debugging. But it's your choice as you're going through this. Okay, so we've got our player coming up here, and it looks a little bit on the big side. So what I ended up doing was scaling it down by half. So back here where we're loading our image, I am now setting the scale to half, so 0.5, so it's half the size. So then what I want to do is I want to spin this player image around as I use the arrow keys. So we are going to be overriding the update function. Okay, so if this .cursors, which we haven't yet added yet, we'll do that in 1 second. So if this .cursors left is down, then what we're going to do is we're going to spin it to the left. So this .player set angular velocity, which is another physics property, to -300. So we're spinning around to the left. Okay, so else if this .cursors right is down, then this .player set angular velocity to be +300. And otherwise, else this .player set angular velocity to 0. So we want to stop spinning if we lift our hands from the keys. So as we did in the main menu state, I'm going to create an entry here for this .cursors. And everything looks good to go. Let's double check that. Okay, that's pretty rad. So the 300 variable for our angular velocity is just how quickly we're spinning left and right. So feel free to play with that. If you want a slightly slower, you know, like if you're making like a capital ship or something in this level, then, or in this scene, then, you know, a bigger ship will turn a little slower, etc., etc. You can really play with it. Okay, so now what we want to do is we want to move forward. So just before this block here of handling the spinning, let's add one for the up key. So if this .cursors .up is down, then this physics velocity from rotation, so we're going to calculate a rotation. We're going to calculate the rotation angle that we're facing, that the player's facing, and then apply some velocity to that. So this .player.rotation, which is what's being updated whenever we call set angular velocity. And we'll apply a 150 of value of speed. And then this .player.body.acceleration. So it's another physics property that we are taking advantage of. Okay, so otherwise, I want to, this player set acceleration to 0. So I want to slow down if I take my hand off the up arrow key. So let's see how this looks. Okay, that's pretty rad. So as you can see, or hopefully you can see, oh, yeah, our player. So now what's happening is our player is going off the scene and we're losing him. So I thought an easy way to fix that is back when we're creating the player is we can call this .player set world set collide world bounds to true. And so what will happen is, by default, the physics definitions for this scene will match the width and the height of our display. So in this case, 800 by 600. And this will be the internal default size of our world. So what we're going to say here is set collide world bounds to true. And then this way our player can only reach the sides of the screen, and then the player will be stopped. So let's go back and check this out. So let's go up to the top, and we're stopped from going any further. Let's go to the right, and we're stopped there too. On the bottom, we're stopped. And if we fly all the way to the left, we should be stopped there as well. And you're right, there we go. So feel free to play with this, of course. In the original Asteroids game, you were able to sometimes, I'm not sure the version, there was quite a few versions floating around, but if you exit one side, you can then come up the other side through the bottom. So if you exit the right, you'll come out through the left, etc. And we'll be doing that with the meteors, but for the player, I thought it might be interesting to just confine them to the constraints of the scene. Okay, so finally, all we need to do is display a score. So in the create method, I've just got a variable here called this.score, and we're going to assign it to 0. And we are going to use the same thing we did in MainMenuScene, which is grabbing the width and the height of our scene right here. So we'll drop that here in the create function. And then we're going to add some score text. So right after the declaration of the player, let's go ahead and add our same bitmap text call. In this time, our x value is going to be, our x position, is going to be the width of the display minus 200 pixels. The height, or the y component, is going to be at 20 pixels. We're going to be using the arcade font, and we're just going to be defining a score of 000 using the font size 24. And again, we're calling setOrigin to just help out with the positioning. So that means in the updating, let's go to the very bottom here. As we update our score, we need to update that update text, or score text, sorry. We have to update the score text component that we created in the create function. So all we have to do here is just call this.score text. And then we want to set the text to be the new score. So we're just assuming that the player will be adding to their score. So this.score. Okay, and if we reload, we'll see the score showing up right here. And of course, it won't actually increment because we're not actually doing anything with it. But you can see that it's there. Okay, so now we can start loading a meteor. So I put the meteors and the laser blasts in their own game object, in their own extended game object of phasers, which hopefully makes it a lot easier to organize them and use them in our project. So back in the root folder of our project, let's create a new subfolder here called entities. Create a new file within entities called Meteor. Okay, so what we're going to do is we are going to extend the phaser.physics.arcade.image object. Okay, and we're going to provide a constructor of the scene and then the x and y position of this meteor. So we need to call the super method, passing in the scene and the x and y position that we're passing into this constructor. And then what we need to do is I'm defining 3 different kinds of meteors. So there's a small and a medium and a large. And these are making use of these small, medium, and large texture images that are in our image assets folder. So what I decided to do in the constructor here is create a internal variable called meteor type. But you could call it meteor size, whatever you want. And then I'm using the random function of phaser. So RND between 0 and 2. So this function will calculate a random integer between 0 and 2, which in fact gives us a possibility of three numbers, so 0, 1, or 2. And so we're going to call a simple switch statement of Meteor type. So for case 0, we're going to be calling setTexture to be the smallest. So Meteor small. Okay, and then if we are the middle size, so case 1, then this dot setTexture to be Meteor medium. And then finally case 2, this dot setTexture to be Meteor large. And then call break. Okay, so this should be enough to pick the right texture for our Meteor, which will then automatically set the sizes of this image for us to manipulate. And you'll see what I mean shortly as we see the boxes showing up on the screen. So let's go back into the PlayScene and let's import Meteor from Meteor. And let's just, /entities/Meteor. So let's just create one Meteor right now. After the player, what we're going to do is generate our meteors. So we're going to use a physics object called a group, which is really helpful for manipulating a group of things within Phaser. So we're going to call it this.meteorGroup equals this.physics.add a new group. And then we're going to store our Meteor objects within a Meteor array. So we can call this meteors or Meteor array, whatever you want. Let's use Meteor array for now. Okay, so we're going to just do a simple for loop of 1. We're going to go through one time and just create a single meteor. So const meteor equals new meteor. So remember, for our constructor, we needed to pass in this, which is the scene that we want to add it to. And then we'll just give it a position of 300 by 300. Okay, and then we want to, at the end of this for loop, we want to add it to both our meteor group as well as the meteor array. So this dot meteor group dot add meteor, and we want to use true to add it to the scene. Okay, so then we have this dot meteor array dot push meteor object into that array, and let's go ahead and check it out. Okay, so we've got our meteor showing up. In this case, it's a small one. Let's see if we get a random one next time. And we get a medium-sized one here. That's cool. So how do we get them moving around? Okay, so we can use physics to do that. So in the update function, we are going to be taking advantage of some additional variables that Phaser will automatically send into this function called time and delta. So these are two variables that will help us to manipulate time and help for the animation calculations of each meteor. Okay, so all we need to do is have another for loop. So for const meteor of this dot meteor array, within the update function, we just want to call meteor.update, and then we'll pass in the time and the delta. Okay, now we haven't provided an override yet for our update, so let's do that right now. We are back in the Meteor file, and let's create a update function using time and delta. And all we're going to do is we are going to do some math. Before we do that, let's go back and set up some additional properties. Okay, in the constructor, so after we've decided on the texture, let's give it a random speed. So this dot speed equals phaser.math dot get speed. We'll calculate a speed between 100 and 1. And then we'll provide a direction for this meteor. So this dot direction equals 0. Don't worry, we'll update that shortly. We'll create a random direction for it. Actually, we can do that right now. Okay, so for a direction, we're going to use another random value from Phaser called angle. So we'll be using the phaser.math.randomNumberGenerator.angle. And so this will give us a value between, what does the help say? Between -80 and 180. So it'll give us a random value between that amount. We will also provide an angle rotation. So this dot angle rotation equals phaser.math.rnd, and this time we'll use a number between. So we'll use the between method like we did for textures or for the images, only this time we are going to be grabbing a variable between 0.8 and 2.5. So what we want to do is we want to kind of hide the meteor until we randomly place this within our scene. So what I'm going to do for now is in the constructor of this meteor, I am going to set active to be false, and I'm going to be setting visible to false. So the Phaser physics engine will essentially ignore this meteor until we activate it within our group. And then finally, I'm going to be giving this a factor value of 1, which is just another variable that we'll be using for our update calculations. Okay, so here within update, so if this is active, so if this.active, and what we want to do is we want to update the x position, this.x, by adding to it the this.factor, which is 1 in this case, times the math cosine of this dot direction times this dot speed times the delta. Okay, and then we also want to update y, so this dot y plus equals math dot cosine of this dot direction times this dot speed times delta again. And then we want to update the angle. So this dot angle plus equals this dot angle rotation. So this just gives it a neat little spinning look as the meteor is flowing through space. So back before we can see anything in our play scene, we've created our meteor. And remember that we disabled the visibility and being active. So what we're going to do is now we're going to just apply a little bit of random number generation here. So const exposition equals phaser.math.rnd between 0 and the width of our world, which is 800. And then we're going to calculate a y variable, a y value of phaser.math.rnd between 0 and 600. And then we're going to set the position of that meteor to be the new xpos, ypos. Okay, we've given it a direction and a rotation. So now we are going to set the active to true, and we're going to set the visible to true. And let's see how this looks. Okay, that's pretty cool. Look at that meteor. Okay, so remember what I was saying before about the world boundaries. So we define the player as hitting the world boundaries and not being able to go past them. But for the meteor, what I want to do is as the meteor leaves one end of the game field, it's going to come in through the opposite end. So all we need to do in our entity, our meteor.js entity file here, is back in our update function. Let's go ahead and just do a little bit of bounds checking. So if this.x is less than 0, so if we've gone to the left, if we've left the left-hand side, then we pop in on the right-hand side. Else if this.x is bigger than 800, then we pop it back in on the left-hand side. So x equals 0. And we want to do the same thing to the y. So if this.y position is less than 0, then this.y equals 600. And if this dot y is bigger than 600, then this dot y equals 0. Let's give that a shot. Okay, so we got a slow moving meteor this time. So let's wait for it to hit the boundary. And it should then pop in the other side, which it does, and continues on to pop out the right and come in the left. Perfect. And we can still zoom around. Okay, so now we can add a laser blast. So we're going to create another entity here called laser. So in the entities folder, create a new file called laser.js. Laser is extending the phaser.physics.arcade.sprite object. And so in the constructor, when we're passing in the scene and the X and Y position of our laser, we're calling the super function, passing in the scene, the X and Y, and then we're defining the texture of laser. So that's the laser image that we will then be shooting. And so let's get a speed. We'll attach a speed to this laser instance. So this speed equals phaser.math.getSpeed, just like we did with Meteor, only we'll go from 500 to 1. And then we'll set the scale of this to be 0.6, just because it looks a little big. Okay, and then so we've already stubbed out the update function here. So we're going to go ahead and just fill a little bit of that in right now. We won't do any bounds checking yet, but we will update it. So this.x plus equals math.cosine this.direction times this.speed times delta. And additionally, for the y coordinate, we have this.y plus equals math.sine this.direction times this.speed times delta. Now you might notice that we don't have any direction defined just yet, and this is just because we haven't actually generated it yet. We're going to define it. We're going to define it when we generate our laser beam. So for now, this won't work because this dot direction will be null, or NaN, I guess, if you try and throw that into math.cosine. Anyway, back in the PlayScene, let's go ahead and import this. So import laser from /entities laser. Okay. And so what we're going to do is same with the Meteor group. We're going to create a laser group. So this .laser group equals this .physics.add.group. Only this time we're going to give it a few additional properties. So we are going to specify a class type for this group of laser. And we are going to define a max size, so we'll only be able to use one laser blast at a time. And then run child update to be true. Okay, so we've got the group added. And then in the update function, let's go ahead and listen for the spacebar. Okay, so if our spacebar is down, then we look for an available spot in the laser group. And if one exists, which means there hasn't been any shot, then we use a function called fire, which is basically to spawn this laser blast, passing it the current player X and Y position, as well as the rotation. And then we're going to be playing a sound effect, which is what we've loaded in our loader scene. So before we can do this, we need to drop in this fire function. So back in the laser again, let's create a function here called fire. And I think it passed in a X and Y and direction. And so this is where we specify the position and direction. Okay, so we update the position to be the X and Y that's given to it. And then we set the active to true, visible to true. And then we set our direction and rotation based on the given direction. Okay, so we should have everything in place for it to update. So let's go ahead and go back to our game. Okay, so we hear the sound effect right away. Okay, but we can only fire one shot, but at least it worked properly, so it traveled to the edge of the screen. So what we need to do is when the laser blast hits the side of the screen or a meteor, then it will remove itself from that group, and then we can spawn an additional laser blast. So how do we do that? Well, with PhaserJS and the physics engine, it's really easy. So all we need to do at the end of our create function, we can do it after adding all of these groups, is we can call a function called overlap. So this.physics.add.overlap. So it will, every frame, the physics engine will calculate if any of the given objects overlap each other. So we're going to use the laser group. So this.laser group, as well as this.meteor group. And then we're going to create a callback function that will then receive the instances of the objects that did end up colliding for this frame of the game. So we'll just call it this.collision, which we'll define right after this. And then we'll specify null for two objects colliding, and then this pointer as a scope variable. Okay, so if there is a collision detected between a laser and a meteor, then we fire a function called collision, a callback function called collision. So let's define that now. So we are passing in a laser and a meteor. So what we want to do is we want to destroy them both. So laser.destroy and meteor.destroy. And then we want to increment the score. So this.score plus equals 10. We want to play the sound effect of that explosion. So this.sound.play, and then the key name of our explosion sound effect was explosion. So let's see how this works. Okay, so we've got a... Oh, okay, so we need to add one more calculation here. So back in our laser.js, in the update method, let's again, basically we'll do the same thing that we did to the meteor. So if we detect that we've hit the bounds of the world, then we will just destroy this instance of the laser blast, which will free up a spot for us to use again. So if this.x is less than -50, or this.y is less than -50, or this.x is larger than 800, or this.y is bigger than 600. So we're going to set active to false, and we're going to set visible to false, and then we're going to call this.destroy to clean it up from the scene. Okay, so let's go back and try this again. Hit space. Okay, we've got our... Okay, there we go. And now let's check out the detection against the meteor. There we go. Okay, so notice our score went up, and the meteor disappeared, and we could still fire. Okay, so now we need to add more meteors, but I thought it might be also fun. I thought it would be fun to add a GameOverScene. So back in our scenes folder, let's add a game over. So new file, GameOverScene. And as you might expect, we're just going to display the text game over. Okay, so again, we're extending the phaser.scene. Let's do it this way. We're extending the phaser.scene, and then in the constructor, we're calling the super method, and we're giving this scene a key name of game-over-scene, and we don't need to worry about anything in the preload function. And then in the create function, all we're going to do is again grab the width and the height of our camera, of our main camera, sorry, and then we're just going to add some title text, which is just a text right in the middle of the screen again saying game over. And then so back in the PlayScene, in the collision callback, what we're going to do is we're going to go through the meteor group And we're going to see if there are any more meteors left. And if not, then we will switch to that GameOverScene. So if this.meteor group count active, so we get a number back of all the active objects. If it's 0, then we want to switch the scene. Switch GameOverScene. Okay, and that should be it. So import GameOverScene from /scenes GameOverScene. So after the PlayScene, we can just use the GameOverScene. And now let's test this out. Okay, hit the space. We've got one meteor, the rogue. Let's go ahead and take it out. And now we switch to game over. Awesome. Okay, this is really cool. And this is pretty much all of the main functionality that we need to put into this game. Now, of course, what we can do is make it look a little bit darker, as a usual Asteroids game might look. So we can comment out the background color. And then by default, a PhaserJS background will be black. And then back in the play scene, let's go ahead and maybe we'll add 10 meteors instead of 1. Okay, so we've got Meteor Swarm, our title, and now we've got our meteors coming up. Now I need a sound effect for the engine. That would be a cool one to add. So like every time you hit the up arrow, you would get like a thrust engine sound effect. Okay, last one, which give us a score of 100. Got it. All right. And yeah, that's it. I hope you had a lot of fun. I hope you enjoyed this video and this project that we put together. Give it a like if you like the video, subscribe to the channel if you want to see more, and leave a comment down below as to any modifications you may have made, or if you want to see more projects like this. I always enjoy doing game development, and now that Phaser's been around for many years, but now that JavaScript and Phaser work so well together most of the time. So I hope you liked what you saw, and we'll see you in the next video, everyone. Peace.